The second technique for making investment decisions that we'll talk about in Chapter 9 is called the payback period or payback analysis. And it's a very simple idea. It's just answering the question, if we make this investment, how long will it take us to get our money back? How long does it take to get the initial cost of the investment back in a nominal sense? The basic payback period doesn't account for time value, so we're just looking at, given the expense of the project and the cash flows that come back, how long does it take to recover our investment? The process is really pretty simple, although it's kind of hard to put down into a formula. There's no real formula for payback period. There's sort of a process for estimating it. Basically, it's this. You first of all estimate the cash flows, and that's, again, going to be the topic of Chapter 10. And once you have them, subtract the future cash flows from the initial cost until that initial investment has been recovered. Here's an example with two projects, Project S and Project L, and you can see the cash flows are kind of similar between the two. $1,000 initial cost for both. Cash flows are 500, 400, 300, and 100 for Project S, and 100, 300, 400, and 600 for Project L. The S and L are intended here to refer to short and long. Basically, Project S will recover its investment in a shorter amount of time than will Project L. Let's see how we go about calculating that. I'll just focus on Project S for the moment and do the calculations there. Here's the initial cost. $1,000 was paid for the investment, and then cash flows, positive cash flows, come back over the next 4 years. How long does it take to get our money back? We'd usually want to express that in terms of years, and probably at least to one decimal place, fractions of a year. It's pretty easy to see that, well, in this case, $1,000 cost, the first two cash flows added together would be $900. That's not enough to cover the initial investment. So somewhere between years 2 and 3, I would expect this project to recover its original cost. But if we want to be more precise about it, we can follow certain steps. Let's talk about that. I would usually start this by creating a second timeline, a parallel timeline with what you might call cumulative cash flows. That is to say, for each point in time, what's the total of all the cash flows that have happened prior to that point? Starting with time zero, as of time zero, when you make the investment, you will have spent $1,000. That's your cumulative cash flow at that point. You're out $1,000. 1 year later, you expect to receive $500 income from this project. So your cumulative cash flow would be calculated like this. Take the previous value, add together the previous value with the incoming $500. The result would be negative 1,000 plus 500, or negative $500 here. So far, we're out 1,000, recovered 500. It means there's still out $500 of this investment. And you keep doing that. Take that value, add to it the next year's incoming cash flow, and put the result here. Negative 500 plus 400 is negative 100. Still a negative number. It still means that we have not yet recovered our investment. So, okay, keep going until you reach a positive number here. Negative 100, adding together with the next year's cash flow of 300 gives us a cumulative cash flow of negative 100 plus 300, positive 200. We could keep going, but there's really no need to stop to continue here because, well, we've reached the point of having more than recovered our investment. After 3 years of cash flows, this project has more than recovered its cost. Exactly how long did it take to recover its cost? Well, Clearly, it was 2 years plus some part of the third year. Um, and again, there's not really a formula for this, but I would do the calculations this way. The payback period is equal to 2, which is this 2 years, plus whatever fraction of the third year it takes to recover that remaining shortfall. At the end of 2 years, there was $100 left to recover. We were $100 short of recovering our investment. And during the third year, we expected to recover $300 from the investment. So, kind of making the assumption that cash flows come in steadily over the course of the year, and that would be a typical assumption, we would calculate this payback period as 2 years plus the shortfall remaining at the end of 2 years divided by the total cash flow expected during the next year, the third year. And this would come out to 2 years plus 1/3, or 2.333 years. That's the payback period. Simple as that. Again, it's not a formula that I can just point to values, plug in variables, and get a result. It's a little bit of a process to calculating this. I hope it makes sense. It's a very simple process and very simple notion to understand. How long does it take us to get back the money from this investment? You could go back, you can see on the previous slide, I had the answer to the question. We calculated a payback period of 2.33 years for Project S, and for Project L, I'll leave it as an exercise, but you can see that certainly 100 plus 300 plus 400 is only $800, so it's not fully recovered. Somewhere between years 3 and 4 is where the payback period will occur for Project L, as opposed to 2.33 years for Project S. The answer is here, but I'll let you work through that second one if you want to, just to double check that for yourself. I said on the previous slide that the decision rule was this: to accept the project if the payback period is less than some preset limit. We like projects with shorter paybacks. It'd be nice if we could invest $1 million today and get $2 million back tomorrow and have a very short payback. That would be great. But generally, we like to get our future cash flows back sooner rather than later. So we like shorter paybacks rather than longer paybacks. And companies will implement policies that specify we only accept projects that have a payback of less than 4 years, for example. It would have to be specified in the problem what that limit was. We'll talk more about that in a bit, but that's how the payback period would be used. I said here, the process of calculation is not all that hard. I said at the bottom here, obviously all else equal, we would prefer to get our money back sooner rather than later, so we'd like Project S better than Project L. But it's not necessarily correct to say that all else is equal. Payback period, as a way of evaluating investments, has quite a few flaws, problems with it, that make it not necessarily desirable as the primary decision-making rule. It does have some benefits. It does tell us some things about how long our money will be tied up in the project, which is a useful thing to know. It does tell us something about risk, because cash flows that are expected in the distant future, like if we were looking at a project with cash flows 10 years or 20 years out, well, those cash flows would be pretty uncertain. So if we're relying on those far distant cash flows to make up our investment, it's probably telling us that it's a pretty risky project. Problems, though, with the payback period are really pretty severe. First of all, it ignores the time value of money. An example that illustrates that. Here's two projects, Project A and B, which have similar cash flows but not identical. Both projects have an initial cost of $1,000. They have cash flows which are similar in that the values are the same, 400, 300, 100, and 600 for A. Same values, 1, 3, 4, and 6 for Project B. Same values, it's just that they appear in different orders. In fact, it's just the first year and the third year cash flows have kind of reversed their positions. We know that we like projects that return the invested capital sooner rather than later. And pretty clearly, you can glance at this and see that, well, it looks like Project A gives us this $400 cash flow back sooner. Project B makes us wait for year 3 to get that back. Just intuitively, it should make sense that Project A is a better project. It gets more of our money back sooner rather than later. But if you go through the process of calculating the payback period for each of these, well, again, $1,000 initial cost, 400, 300, and 100, that's $800 in total. Payback occurs somewhere between years 3 and 4, and it's the same for both projects. You can verify this if you like, but the payback period will be exactly 3 1/3 years for both of these two projects. So if you're asked which is better, and you try to answer that question based on the payback period, you can't. Both of them have the same payback period. Neither one is better than the other, even though just based on intuition, we know that according to the time value of money, we like to get our money back sooner rather than later. So it's kind of important that Project A gets that big cash flow in year 1 rather than year 3. It's definitely better to receive cash flows sooner rather than later. So you should be able to distinguish between Project A and B. You should be able to tell that A is better than B. Payback period doesn't do that. One way of saying that is to point out that payback period ignores the time value of money, basically ignoring the fact that cash flows in year 3 are less valuable than cash flows in year 1, and assigning equal value to that $400 cash flow, whether it happens 1 year from now or 3 years from now, is really a mistake. Here's another pair of sample projects that serve to illustrate a problem with the payback period approach. Projects C and D, and again, just for simplicity, they all have these simple $1,000 initial investments, so we can compare them easily. Project C is a little bit different. It has cash flows of $400 each year for 4 years. $1,600 coming back in total on a $1,000 investment. That seems pretty good. Project D's cash flows are a little bit different. We could calculate the payback periods for these, and again, I'll leave it as an exercise, but clearly 400 and 400 is 800. That investment is not recovered after 2 years, but after 3 years it is. So somewhere in between years 2 and 3 is the payback period. Project D has a different set of cash flows. 100 and 300 is 400. 400 more is 800. Project D does not pay back its investment after 3 years, but clearly it does after 4. So the payback period, again, somewhere in between years 3 and 4. You can calculate those, and I've got them calculated here. And you can go through the cumulative cash flow process to duplicate that for yourself if you like. But the paybacks are 2.5 years for Project C and 3.33 years for Project D. We like projects with shorter paybacks, so we choose C. Pretty obviously, though, if you look at the cash flows, Project D has a benefit that's not being captured. You would be making a huge mistake if you chose Project C because it has a shorter payback and ignored Project D because it has a longer payback. You'd be ignoring this giant cash flow occurring in year 5. That's kind of an unrealistic example, but it certainly serves to point out the fact that any cash flows that occur after the payback period are ignored when you analyze a project using the payback period. That can lead to a pretty big mistake, ignoring the fact that what may be a bigger investment generates cash flows over a longer term and therefore is more valuable. It's not necessarily a good way to analyze a project. Back here on the summary slide with the benefits and the drawbacks of payback period, I mentioned a couple of these already, and we just demonstrated that, well, the time value of money issue is a pretty big one. Projects A and B were not the same, even though they had the same payback period. Their present values would be quite different. Projects C and D example proved that if you ignore cash flows that occur after the payback, you may be ignoring something that's pretty important. So that's another reason not to choose the payback period. A third reason is that there's no real objective decision rule. With net present value, we said that a project is a good project if it has a net present value that's positive, if its benefits outweigh the costs. And that's a very objective, simple thing to determine, and it's grounded in theory. It makes sense. With payback period, there is no theory, there is no science that says a 3-year payback is good and a 4-year payback is bad or anything of the sort. Managers can tell you that we don't accept projects with a payback of more than 5 years, but that's really just kind of arbitrary. There's no scientific grounding behind it, so we finance professors tend not to like that. It is in use. People do use the payback period, at least as a secondary way of evaluating projects, but I'm advising you here, and the book does too, that it's not really the best thing to use as your primary decision-making tool in finance. There'll be one more video in this chapter covering the internal rate of return as a third way of evaluating projects. Stay tuned for that.